Hello and welcome back to App for You. In this particular video, we will be discussing another variation of the problem we discussed in the previous video, right? So in the previous video, we already discussed a problem wherein we were asked to find or check whether there is a loop or a cycle in the linked list or not, right? So that particular objective was already completed in the previous video, wherein we were asked to find whether a linked list consists of a cycle or not, right? Having said that, in this particular video, what we will do is, if we find a cycle in the linked list, we need to find the starting point of the cycle, right? Or in simple words, if we just focus at this particular example, alright, we know that the cycle was detected in this linked list, right? So what is the starting point of the cycle? So basically we can say that this particular node is the starting point of the cycle, right? Because you can see this node is visited twice, right? Once you visit while going and once you visit it while returning. So basically this is the point of conflict, right? Because if this is where the actually loop starts and ends, right? So this is the point we have to detect, or you can just say that this is the point which we have to return, okay, that this is the specific node where the cycle starts and ends. So how do we solve this particular problem? Is it something different from what we discussed in the previous problem? No, absolutely not. This problem will be just an extension of what we discussed in the previous video, right? So the logic remains the same. In this particular video, the objective will be to detect a cycle. If there is a cycle, then we need to find the start node of the loop. Alright, so far so good. Let us proceed. So in simple words, this will also follow the Floyd cycle detection algorithm, right? As always, we will have a slow pointer and a fast pointer pointing towards the head node, right? So the slow pointer will take one step at a time and the fast pointer will take two steps at a time. Considering the first iteration, initially they are here, fine? Alright, suppose it is at t equals 0. This is the initial condition. What happens after the first iteration? The slow pointer takes one jump, the fast pointer takes two jumps, right? Similarly, in the second iteration, the slow pointer takes one jump from here to here and the fast pointer takes two jumps from here to here. You can see here, right? What happens in the third iteration? Again, the slow pointer will take one jump, so from here to here, right? And fast pointer will take two jumps, so it reaches here. Getting the point? What happens in the fourth iteration? So in the fourth iteration, basically, the slow pointer was initially here, so it will come here, right? In the previous iteration, slow pointer was here, so it comes here, and the fast pointer was here, so it will come here. You can see it is pointing to this one. What happens in the fifth iteration? The slow pointer moves here, the fast pointer will move here. The fast pointer has arrived here, the slow pointer has arrived here. What happens in the sixth iteration? The slow pointer takes one step, so it reaches here. The fast pointer will take two steps and then it will reach the same node. What is the conclusion? The conclusion is the cycle is present because we found a condition wherein both the slow pointers and the fast pointers are pointing to the same node, right? This we completed 60% of our job. Okay, 60% of our task was to check whether a cycle is present or not, and we have already written a code to detect the cycle in the linked list, right? So the code for detecting cycle in the linked list using two pointer method is already discussed. Now we need to find whether we need to find what is the point which is the starting and the end of the cycle. So in other words, let me just clear all the ink on the slides. So basically we met at this point, right? The both pointers were moving at their own speed, and this was moving at a speed 1, suppose into 1, and this was moving at into 2, right? And we know that if they are moving at different speeds, okay, they will meet only if there is a circuit. So definitely a circuit was present and they were moving in the circuit, and hence they met at this point. Now remember, both the pointers are at this point. At this point we concluded that a loop is present in this particular linked list. Now we need to find this particular point. How will we find this particular point? The logic is quite simple. What we need to do is, once you detect the linked list, okay, once you detect the linked list, make the slow pointer point to head node. Okay, the linked list cycle detection task is already over. Now move the slow pointer back to the head node, right? Move the slow pointer back to the head node, and now in every iteration, okay, until slow pointer and fast pointer meets at a point, let them move one step at each iteration. So in the one iteration, slow pointer moves here. In the same iteration, the fast pointer will come here, okay? In the second iteration, slow pointer moves here, the fast pointer will move at this point. In the third iteration, slow pointer moves here and the fast pointer will move at this point. And you can see that when slow pointer will be equal to fast pointer, then that particular node will indicate that node where the cycle has started and terminated. Alright, so I hope you got the point. The logic is quite simple. Once the cycle is detected, the slow pointer and fast pointer are pointing to the same node. So what will we do? The slow pointer will now point to the head node, right? And now until slow pointer and fast pointer becomes equal, both of them will take one step at each time, at each iteration. Okay, so this time their speed will be equal. Both slow pointer and the fast pointer will take one step at each iteration, and finally we will see that they are meeting at a specific point. The point at which they meet, or the node at which they meet, is our objective node, is our node which is the starting and the terminating point of the cycle, right? So I hope this was quite intuitive. Let us now quickly see what will be the modification in the code, right? So considering the code, so this is the code. What is the modification actually? So we can see that in this particular problem, the problem is quite similar. I have already shared this code for cycle detection in the drive, and the link is in the description. Okay, so this was the code for cycle detection. We know the slow will point towards the head, the fast will point towards the head initially, and if these nodes are valid, the fast and fast to node next node are valid, and basically slow will take one jump and the fast will take two jumps, right? This is already, we are familiar with this. If slow is equal to fast, it indicates that both the nodes are pointers are pointing to a specific node, and hence it indicates the loop exists. So I am using a variable loop exist. Okay, so loop exist is a global variable I have declared, because this will become one whenever the loop will be detected. So loop exist I have declared globally. This will become one whenever the loop will be detected. So what I have done is basically, as soon as a loop will be detected, the loop exists value will become 1, right? And it will terminate. Loop exist will become 1 and it will break. Break means our task is already over. We have already detected the loop. What will we do now? Now if loop exists, means now if we have already detected the loop, we already saw in our discussion right now that if we detect a loop in the linked list, the next task will be to move the slow pointer back to head. Okay, so once we detect the cycle in the linked list, the next task will be, so if loop exists, the next task will be to move the slow pointer point towards the head node. And now until slow and fast pointer become equal to each other, what will we do? The slow and fast will take one step at each time, at each iteration. Okay, and finally when slow and fast becomes equal, this loop will terminate and we will then return slow. What is slow? Slow is nothing but the node to which this slow pointer is pointing to after they met. Okay, the point at which they met. And if they never met, then obviously it will become return null. But obviously this should be returned because we know that a loop exists in the linked list. So this slow will be returned, and finally you can see so here it is. If loop exists equal to 1 means if we know that the loop exists, then obviously we should have the starting and the ending point. So temp data, and what is temp? Temp is a pointer I have declared which will store the address of the address returned by the detect cycle function. So detect cycle function will return the address of slow pointer, right? That pointer's address and the last time where they met, where both the slow and the fast pointer met, right? That particular address will be returned here. It will be stored in the variable temp. Temp data will give the value of that particular node, right? So if I just execute this particular problem, so loop starts from 3. So this basically was I have declared a linked list manually, and it is saying that loop is starting from 3. If we just look into the linked list, how it is, basically the structure is like this: 1 2 3 4 5. And if you just go through the function I have already provided in the description, the linked list will look somewhat like this: 1 2 3 4 5. Okay, and what has happened here is head next. So head is basically pointing to this. Okay, this is head, and this has been made null. So head next, head next, 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 next. So head next, 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 right? So 1 2 3 4 5 times next. So 1 2 3 4, and 5 times next is equal to what? So it is equal to head next, next. So head next, next means this point, this node. So this is pointing to this node. So you can see that the point 3, the node 3, this is a point where the cycle has started and the cycle is terminating. So this should be the answer as per this particular structure of the node, structure of the linked list, and obviously we got the same. We got answer 3 only, right? Answer is 3. So that's all from this video. I hope this video was helpful. Please like, share and subscribe, and that motivates me a lot. and thank you for watching.